Hi, guys, and welcome to our second chapter of second semester. We're going to actually be continuing with chapter 8. In the first half of chapter 8, we gave you two polynomials that you multiplied together to make a longer polynomial. In this half of chapter 8, we'll be working backwards. So what used to be our answer will now be our starting problem. So we'll start with a very long polynomial. And our job is going to be to try to figure out what were the two parentheses or factors that the problem had started with. We're going to start off a little bit slow, make sure that you feel really confident about the vocabulary and about making sure to find a greatest common factor or a GCF, and then we'll work our way up into the more difficult problems. In this video today, we're going to be focusing a lot on vocabulary. Our first vocab word is factors. So a factor is a number or variable that divides evenly into the original number. So you want to think of like numbers, they usually come in pairs, two numbers that can multiply together to make whatever the original number was. For our first example, we're going to find all of the factors of 72. To help us find all of the factors and not just like some of them, we're going to go through a process to make sure that we hit every number that we can think of. For this process, we're always going to start by just doing 1 and the original number. So for this problem, it's going to be 1 and 72. 72 is divisible by 1, and 72 is divisible by 72. Then what we'll do is we'll take the number 1 and we'll try the next consecutive number, which would be the number 2, and we'll see if that's a factor. And if it is a factor, then we can write the next pair. To see if it's a factor, you're going to do 72 divided by 2. And it works. 72 divided by 2 is 36. So my next pair of factors is 2 and 36. Next, we'll try 3. 3 also works. 3 times 24 is 72. That means 72 can be divided by 3 and 72 can be divided by 24. Next, we'll try 4. And 4 also works. It's 4 and 18. We're going to hit our first number that doesn't work. The next number we would try is 5, but 72 is not evenly divisible by 5. Next, we'll try 6, and 6 does work. It's 6 and 12. Then we would try 7, but 7 does not work. It will give us a decimal if we divide it in a calculator. Next, we'll try 8. Now, 8 does work, and 8 gives us 9 as our answer if we divide it. Since our next number that we would try is 9, and 9 is already part of our list, we're done. We have definitely, beyond a shadow of a doubt, listed all of the factors of 72. So this is just a nice little process to make sure you don't accidentally miss any. These, again, are all the numbers that can divide evenly into 72. Here are some other vocabulary words you need to know. A number or a polynomial is prime if its only factors are 1 and itself. So if you can't make that huge list, if your list of factors is just 2 numbers, then we call it a prime number. If you can get at least one more number, a third number, then it's called composite. So a composite number is something that has more than 2 factors. So 1, the number, and then at least one more factor, then it's composite. Here are the prime numbers up to 20. So this is going to help you with our next example. Make sure to write these down in your notes. For our next example, we will be finding the prime factorization of a number. So now this is a little bit different than our first example, because in our first example, I just wanted all of the factors, but in this example, I want a list of prime numbers such that if I multiplied them all together, it would turn into 384. To find that list, we're going to do something called a factor tree. For a factor tree, you're going to take the original number and you're going to split it into its first set of factors. So a number times another number that equals 384. For me personally, I like to just always start by dividing by the number 2 if I can. So I'm going to divide this by 2 and I get 2 and 192. The next thing you're going to do is you're going to split these again into two numbers. Now, if the number is prime, so if it's on that list of numbers we just wrote down, then you would stop that part of the tree. That would be the last branch. But if the number is composite, you would keep going. So the number 2 is prime, so I will not break that down anymore. But 192 is even, so I can divide it by 2 again. 96 also even, I can divide by 2 again. Look, I'm getting a nice long list of the number 2. 48 also even, I can divide by 2 again. 24, we've got another even number. 12, another even number. And 6, another even number. Now at this point in time, I've only got prime numbers. So 2 and 3 are both prime. And so I cannot make any more branches on my tree. And so I'm ready to write my prime factorization. For our purposes in this class, it's going to be best for you to write your prime factorization as a long list of numbers and not using exponents. And I'll explain why when we do tomorrow's video. So let's write this. I had 1, 2, 3, 4, 5, 6, 7 number 2s, and then the number 3. If you also start by just making that long list of 2s, it'll make it easier for you to find your prime numbers when you're done with the problem because they won't be mixed in with your composite numbers. Go ahead and check that on your calculator and make sure that 2 times 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 3 does equal 384. This again is called prime factorization. This is not all of the factors. This is the prime factorization. Now we're in algebra class, so we're not just going to do factoring on numbers, we're also going to be factoring with variables. So let's take a look at this problem, and we want to again write the prime factorization, and in this question it's 81b squared c to the third. So for the coefficient part, the 81, we're going to do the same thing we did on the previous problem, which is we're going to do a factor tree. Now, 81 is not divisible by 2, so maybe we don't go to 2. And I think our first instinct when we see 81 is to do 9 and 9, which is totally fine. Each of these 9s is composite and can be split down into 3 times 3 and 3 times 3. When you're writing your prime factorization, you only want to use the numbers from the very edge of the branch, so don't use anything that had already split. So for this prime factorization, I'm going to have 1, 2, 3, 4 number 3s. And then you do want to also write out your variables as long as you can. So the exponent tells us how many of each letter we should be writing. And so if it's b squared, I'm going to write 2 letter b's. And if it's c to the third, I'll write 3 letter c's. And so my prime factorization for this question is 3 times 3 times 3 times 3 times b times c times c times c. Now, again, writing it out in this really long format is going to be so helpful when we do tomorrow's videos. So please get into the habit of writing it all out without any exponents. To help you get in that habit, we're going to try these 3 problems on your own. So please do these in your notes, and then you can pause the video and check your answers when you're done. If you're struggling, here are some helpful hints. If a number is even, you can always divide it by 2. And that's my go-to when I see an even number. If you add all the digits together and the answer to that adding problem is divisible by 3, then the original number is also divisible by 3. Let's take a look at these examples. 2 plus 0 is 2. 2 is not divisible by 3. So 20 is not divisible by 3. For 36, 3 plus 6 is 9. 9 is divisible by 3. So 36 is divisible by 3, and also 2 because it's even. Let's check 32. 3 plus 2 is 5. 5 is not divisible by 3, so 32 is not divisible by 3. If your number ends in a 0 or a 5, then it is divisible by 5. So in our examples, that would be the 20. And finally, if you are dividing and you just keep dividing in your calculator and you're getting nothing but decimals, and you do a division problem, and the number that you divided by is bigger than what the answer was to the division problem, then you can stop. There's actually no more factors to that problem. You're probably reached a prime number. Okay, so if you divide, let's say you divide by 6 and your answer is 4.2, you can stop trying. There's no more divisors. All right, let's check and see how you did. And so here are the answers for 1 and 2. So for question 1, it's 225. And for question 2, it's 2233. And for that last one, I want you to choose the correct answer on the multiple choice question from this video. Don't forget when you're done to come back to the video and make sure that you watch it to the end. All right, guys, that's all for me for today. You have a textbook assignment tonight, but we aren't going to start Delta Math until tomorrow. So just a textbook assignment, and I will see you tomorrow.